My name is Tom Hollingsworth. During the day, my Bruce Wayne job is working with Steven at Gestalt IT on the Tech Field Day series and a bunch of other things. But at night, when I go down into my cave, I get to be Batman, the networking nerd, the vendor vigilante, and I get to say all kinds of fun things on the internet. And we were putting together the community sessions for this event. Steven's like, well, I think you should give something back to the community because we know Eric's had a great talk about community and so did Alistair. I'm like, well, what do I have to offer a bunch of virtualization guys? He's like, I don't know, talk about networking or something. So I'm going to talk about how networking is exciting again. And a lot of you have already asked, well, networking was never exciting, or what are you talking about? Networking is exciting now. I'm going to tell you why networking is exciting again, and we're going to cover a few things that you probably have been hearing about, and some of them you've actually heard about at this event. But I wanted to go into a little bit more detail about them so that you guys could have an understanding with your networking team when you go back, so that it's not like the Hatfields and the McCoys. So before we get started, there was a blog post that went out the other day from one of my networking friends that said that Tom knows everyone in the world. And I said that's not entirely true. There's like 4 people that I don't know. And Rob Novak actually said that's probably not the case. You don't know everyone, but everyone knows who you are. So just in case there are people out there who don't know who I am, I'm a CCIE. And I have to put that first by law, because when you talk about networking and you don't have those numbers after your name, people don't believe you for some reason. So yes, I am a CCIE. It only took me 7 tries to get it. In the meantime, I started a blog. So I am a blogger at networkingnerd.net. I also write at networkcomputing.com and some other reviews on Amazon, the crazy ones. I speak at events, usually some bigger than this, but none are more important. And I also tweet at Networking Nerd. In fact, I've gotten to the point where I just introduce myself by my Twitter handle anymore because it's easier. A little bit of snark there, just so you know. And I like the term prognosticator. Why? Because I like to make wild guesses about what's going to happen and then smile when I was almost right. So there's my LinkedIn profile if you actually care. Most of the stuff that I do gets cross-posted everywhere, so just follow me on Twitter. It's easier. This is the agenda. We're going to talk about the exciting times going on in networking, and then I'm going to define software. And then we're going to talk about network function virtualization, which you guys have heard about already. And then I'm going to talk about overlays and underlays, because that's where the rubber meets the road for you guys. And then we're going to wrap it up. I should warn you, if you haven't figured it out already, I'm a huge pop culture nerd, so I'm going to have a few references in here. Feel free to laugh when you see them. So why is networking exciting? Well, I'll tell you right now, the last decade in networking has been pretty damn boring. Why? Because we solved everyone's problems. Engineers are really awesome at that. We find a problem, we work on it until our fingers bleed, and when we actually solve it, just like Eric said, we walk away from it. If the smart ones will write something down, it's like, oh yeah, that's how I fixed that problem, and then we walk away. 12 years ago, networking was hard. How do I get a Bay Networks router to operate with this Cisco thing? How do I get all these encapsulation profiles to work? ATM, that kind of thing. Well, we fixed all that. We standardized on Ethernet. OSPF actually works. So what did we do in networking for the next decade? We made everything faster. 10 meg, 100 meg, gig, 10 gig, 100 gig, 40 gig. They're terabit Ethernet.
40 is smaller than 100. You didn't go in order.
Math is hard. We just made it bigger and faster, and we didn't care. But networking is still pretty hard when you look at it, because we still have to log into switches and create VLANs. We still have to architect things. Little tiny changes that we make in the network can have huge catastrophic effects on everything. And that's usually when the virtualization team comes running downstairs going, what did you touch? So networking is still hard even though it's fast, and it can cause huge problems. How do we fix that? Well, if we keep doing it the same way we've always been doing it, which is just take a look at it and make it just a little bit better every time, we're going to have the same crap we've had for years. It takes real genius people to look at the problem from a different perspective and say, I need to solve this in a new and unique way. One of those guys is Martin Casado. This is actually his resume from Stanford. Martin is a genius, and if he's watching, hi Martin. I'm sorry for the picture, by the way. Martin worked at Stanford. He actually went there for school, and he got involved in the High Performance Networking Project. It's part of their Clean Slate program. If you look at Clean Slate on their website, what it says is, we don't want to keep solving problems in broken ways. What would happen if we took everything we know about networking today and threw it out the window and started from scratch, would we rebuild networking the same way that we did 10 years ago, 20 years ago? We had limitations we had to work with. I can still remember reading my first networking material and hearing about how OSPF was an expensive protocol because it required so much processor utilization. Now I can run OSPF on a pocket calculator because the CPUs are just so huge. I mean, we can buy a supercomputer in a 1U form factor and we can run anything we want on it. And you're going to tell me that networking is expensive? No. So one of the things that Martin looked at was his network at Stanford. He said, I've got this gigantic research network that I can't touch because if I try to change anything and it breaks, I'm going to get fired or thrown out of school. So his idea was pretty revolutionary at the time. What if I could take and slice off sections of my production network and use them as lab during the day, automatically return all of that, those resources back to the network when they need them, like when a backup window happens. I can still have a big network to play with and not break anything. And so that's where the idea started to create the protocol OpenFlow. OpenFlow's initial spec was network slicing. If you look at the 1.0 spec, that was the big feature release. That started the ball rolling with SDN. This was 2 or 3 years ago that people really started looking at it going, hey, this is going to change the world. So SDN, you hear it, you're sick of it, what is it? Nobody knows. SDN is whatever I want you to believe it is. It's a puzzle. Initially, this was the definition. We've decoupled the control plane of a network from its data plane. That's pretty generic, and it doesn't really tell me a whole lot. Every switch and router in your environment has a discrete control plane and a discrete data plane. Data planes are easy to fix. They just forward packets. They're stupid. They do what they're told. Control planes, on the other hand, are they're a little difficult. Networks are deterministic. If you go hop by hop through a network, every packet has to make a new decision at every hop about where to go. The control plane of that device is God as far as the packet is concerned. But that's stupid. We don't build other systems that way. What if the only way you could manage a virtualized server was to be logged into the ESX host that it was on? Could you do anything like vMotion, HA, DRS? Services that we use today are very, very important, would cease to exist without some kind of overarching control plane for all of my control planes. Well, as time went on, this definition stopped being so important because, like I said, SDN is whatever I think you want it to be. Vendors started saying, well, I'm going to use my own definition of SDN to repackage my old stuff and make it sound new and exciting, and I'm going to sell it to you in the hopes that you won't figure out it's not SDN. There's actually an RFC that went out this week, and I believe in my notes it's RFC 7149. It was written by 2 guys from Orange Communications in France, and they said, you know what? SDN is a lot of hype, and we want to make an actual, real RFC, an informational one, to talk about how networking is not hype. They actually used this definition in page 3. SDN is not just decoupling control and data planes. It's creating a deterministic, dynamic, and scalable network through methodologies. Think about that, deterministic. The entire network now knows a data path. Dynamic, I can dynamically reroute that path in the event of a failure. It's scalable. If I have to drop 90,000 new CAM table entries onto a device, it's not going to fall over. That's what made Google so excited about SDN at first. That's why Facebook loves it. It's because when Justin Bieber tweets something stupid and all of a sudden 100,000 people want to go like a new photo of it, I don't have to worry that my network is going to crash because SDN will scale around that. It will dynamically adjust to those loads, and it will make sure that all those likes get delivered where they're supposed to. Just like any good cake, I don't know how good that's going to be. It actually looked a whole lot better when you're finished with it. SDN really has 3 simple parts. It's orchestration, it's automation, it's programmability. If your SDN solution doesn't include all 3 of those things, or at least one of them, you're not selling SDN, you're selling snake oil. Let's talk a little bit about each of them. Orchestration. You guys are very, very, very familiar with orchestration if you work with VMware, aren't you? And not just regular orchestration either. There are layers of orchestration. There's a wind section and a string section. Why? Because every piece of a solution has different requirements. In networking, it's no different. OpenFlow's initial, what's the word I'm looking for? OpenFlow's appeal to people was the fact that there is one device in your network that has knowledge of every networking device, a controller. If I have that data, I can do crazy things. HP actually showed us a demo at Interop last year where they have a live Visio-style map of a network. And I can show you all the paths that your traffic are taking. I can pick a specific host and tell you everything that he can see. And he can see the whole network now, not just the next hop. It's amazing that you get that kind of clarity and you can see problems start happening in real time. Oh, the multicast link on this tree started to fail because too many nodes were traversing it. Well, why don't I just redirect those packets? Our router in Tahiti went out. Crap, now I need to find a new way. Think about it from a perspective of expensive WAN links, because let's face it, for whatever reason, WAN connectivity is still ridiculously expensive. What if I have two links that are both roughly equal in performance, but one of them costs 10x? Which one should I use? Not the 10x one. But how do I know that that data is not going over that path? Well, I don't right now, because if you use equal cost load sharing, some of that traffic is going to go over the 10x link, and I don't want that to happen. With orchestration, I can see that, and I can prevent it. The first demos of SDN using OpenFlow are all about path selection. That's the hello world application for SDN. So you'll see that a lot when you start getting into it. But orchestration is important, because without orchestration, none of the rest of this can happen. But we also have to automate the network, because quite frankly, I'm getting tired of CCNAs blowing things up. Have you ever seen one of these? It's the most awesome machine ever made. How many of you in here know how to make a pancake? Make them every Sunday for my kids.
There's an OK button on the front. That's how you make a pancake.
Exactly. Pancakes are not exactly specialized knowledge, but they're also really easy to screw up. I can burn them, the mix can get too thin, whatever. My kids hate most of the pancakes I cook. I have to drown them in syrup or things like that. But these things are awesome when you go to the Holiday Inn, because you literally hit the button and 2 minutes later a pancake pops out. And it's perfect every time. Why? It's not rocket science. Pour in the mix and the thing takes care of itself. This machine in a network is perfect, because remember how I told you that networking is still a very manual process? How many times have you guys ever typoed an IP address or a VLAN or any other piece of information that's a random string of numbers that have no meaning? You typo a VLAN in a network in the wrong spot, the whole network goes down. Or worse, it wrecks the network, and then you have to spend the next 4 hours figuring out what the state of the network was before. Because without orchestration, I don't know what the configs of these switches were, other than just copying and pasting them into Notepad so that I have a backup somewhere. This is why people are scared that SDN is going to kill people's jobs. It is. SDN is going to put some very low-level people out of business. The monkeys that I use on the CLIs to go out and say, okay, you know what? I'm going to go ahead and program this VLAN day in and day out for the next 3 years until I've earned my keep and I can actually play with architecture pieces. I don't need those guys anymore. I can use this pancake machine to do that. It means that the people who are left in networking have to be smarter, though. They have to be architects. They have to be engineers. They actually have to build things, because now all of that's going to be handled by scripts like Alistair's from Autolab. How long would it have taken you to put Autolab together if you had to build that lab every time?
Autolab wouldn't exist if there couldn't be automation.
There you go. Because now Alistair's not worrying about the nuts and bolts. That's what I want to get past. I don't want VLAN jockeys. I want people who think about networks in a different way. Programmability. This is the one that everybody loves. Because guess what? CLIs are dead. No, not quite. Why do I have to telnet or SSH to a switch to interface with it? Why do I have to use the VI client or the web client to go to every ESXi host on my machine, on my network, and fix things? It's a dumb idea. It really is. Why do we have APIs? We have APIs so that I can write my own code to interface with your device. So now, instead of having to know what Cisco CLI is or the Juniper CLI, all I need to do is know what your API exposes to me, and then I can write it in whatever I want. Python, Perl, Ruby. If you want to write it in assembly, you can. This is where the power is coming from the vendor side, because now I can start tying everything together when every device on my network has an API. Cisco's doing it with 1PK. We're taking all of our old stuff and we're sticking APIs on the back side of it, and we're going to let you write a controller to touch it. And now you can start doing all these crazy awesome demo things. But everybody else is doing the same thing. Juniper's actually had a lot of API support for a long time. You can throw some crazy naked XML at the thing and it'll just work. It'll figure it out for itself. Programmability is where guys like me are scared because I have to go back and remember all those programming classes I took in college. And it's hard, but now I don't have to worry, well, you can't do this on a Juniper box because you're a Cisco guy. No, you're a programmer. Write a program and make sure that it touches all the APIs that it needs to touch. And we don't have to worry about, you're just a Cisco guy or you're just a Juniper guy. Plus cookies are awesome. So, if you have those three components in your system, you have SDN. So build on it. Now when people come to you and go, oh, well, this is an SDN solution, you can look at them and go, I don't see any APIs. So what's your orchestration layer? You don't have those? Come on, guys. Is it automated at least? Because if it's not, I can write a script and I can replace you. So SDN is actually pretty simple. But SDN is not the only thing you guys are having to deal with. And one of the ones that I saw at Spirent yesterday was about NFV. Anybody recognize that movie reference? Thought about NFV. What is it, really? Highlander. Remember when Connor McLeod chops the guy's head off?
There can be
what happens? The quickening. So what is the quickening? The quickening is what happens when you steal an immortal soul. Everything he is, his power, his wisdom, and all is discarded from his body, which is now dead, and moved somewhere else. It's kind of like V-motioning a soul. But think about that. Why do I need to have physical appliances in my network? Because God knows we got a ton of them. Firewalls, IDS, IPS, WAN op, compliance, whatever. Everybody's got them, and they stack up in the back like crazy. But they're all on hardware. So what happens when that hardware starts dying? Well, it was a specialized box because I had to have a crypto card in it to do all these crazy SSL VPN terminations. Well, the crypto card's not supported anymore. I ran into this in my old job as a voice engineer. We had a very specific set of rules for what a voice server could look like. I had to rip a processor out of a server one time and actually put a slower one in because the processor was 200 megahertz too fast for the installer to understand, and so it threw an error. What kind of crap is that? That's not how you build systems. So NFV is all about taking those physical systems and virtualizing them. Sometimes it's easy, sometimes it's not. NFV in and of itself means nothing to you guys because guess what? You've been virtualizing servers your entire career, most of you. What can I do with it once it's virtual? It's not just about scalability anymore, or redundancy. Now I don't have to worry about the hardware dying. As I started thinking about NFV when I was writing for network computing, I realized that it has no value to anyone, but the service providers really, really are going to drive value out of it. So imagine this. Everybody in this room has a phone. And even if you run Windows Phone, you still have an app store, right?
Just an empty one.
Just an empty one. But there's still like one app in there. Would you have written an app for your phone to do something?
Haven't yet.
You haven't yet, but and as a programmer now, because we're all programmers, it's difficult to come up with that idea, that initial idea, and code it and test it and make sure that it doesn't break everywhere. But when someone else does it, oh yeah, I'm going to go download tiny, Angry Birds or Flappy Bird or Bird or whatever. And it gives me a service. Now, in most cases, that service is entertainment, but I don't necessarily care about that. But from a service provider perspective, what if I could write code for a WAN optimization appliance or a firewall, and I could put it in an app store. And when you need it, you go out and you give me your corporate credit card, just like Amazon Web Services. And now for $19 a month, you have WAN op at this point in your network. It works because SDN makes it extensible and scalable. It's virtualized so you can move it everywhere. And I know it's going to plug in because you just tell me where you want to drop it. You answer these 3 questions in the wizard and all of a sudden, bing, bang, boom, you're done. You need to scale that. Oh, flip out the credit card. 2 more instances. It's what, $38 more a month? Awesome. They're already doing this. HP demoed an SDN web app store at Interop. That was their big thing. Service chaining is where they're going to end up. So you guys probably work in environments that have compliance rules, right? Silly things like nobody from the accounting department is allowed to get on the accounting server. All traffic that is going to the internet from the student VLAN has to go through a web filter. That was my biggest thing. I've done the dumbest things in the world to networks because I have to find all that traffic and point it through a web filter. So if you've ever watched a 100 megabit network get dragged down by a 10 meg hub because it has to tee off the VLANs that are student facing, and you realize that this is stupid, what if I could insert a network tap in software? That's the first application NFV builds, is a network tap, because it's easy. All it is a software hub. So all the traffic flows that enter this box that are this classification get teed off here and they get dealt with. Packets get punted to a filter or something like that. The rest of them can pass through it. But let's change some more stuff on there. So all of that goes through a firewall now to make sure that the people who are not in the accounting department don't talk to the accounting server. And those rules are auditable. I can tell you every packet that went to that accounting server because I have a controller that keeps state on them. And those rules are invalid. That's what we're talking about in the limo with Coho data. Punting packets to the controller to figure out which NFS host to pin them to, it's pretty easy to do. That's service chaining. This diagram actually came from Brent Salisbury's presentation from the Open Networking User Group. Thanks, Brent. I stole your slide. But service chaining is what people want because they don't want to sell you a one-off appliance that they're going to have to support with warranty for years and years and years. They want you to rent a service from them. They want to be able to keep offering you those services. That's where the real value is for them. NFV is not hard. I won't claim to know everything there is to know about it, but when you realize that the end goal is not to get rid of hardware, it's to make you buy more software, now you know where the vendors are going to go with it. So over is under unger, and unger is underdone, but over's overdone and done is unger over. If you've ever watched Airplane 2, it's one of the greatest scenes ever. Overlay and underlay is the new battleground. It's the Hatfields and the McCoys, it's the Coke and Pepsi of the world. Because there are some people out there who firmly believe that overlay networks are going to win. Even though we've had them for years and they haven't taken over yet, overlays are going to win. But there are also people who are firmly seated in Team Underlay's camp. Because, hey, without Team Underlay, your packets go nowhere. So let's talk a little bit about those real quick. So overlay networking. It's just a series of tubes, really. Overlay networks are things like MPLS. They ride on top of your existing network and they deliver services. And the easiest way to envision them is with tunnels, because that's most of what they do. This is what Martine was working on when someone backed a dump truck of cash up to his house and said, come to work for VMware. Nicira was all about creating an overlay network that runs on top of your existing network. That's why they can get away with saying things like, your networking team doesn't matter anymore. You guys are all networkers now. But the problem is that that still doesn't really work right, because tunnels are very simple things. They have an endpoint and they have an exit, or the entry point and an exit point, right? Packets go in one way and they go out the other. They don't take into account things like what happens whenever a switch drops out. They don't take into account what happens when you try to leverage fabrics. In fact, if you go to Brocade, if you go to Juniper, if you go to anybody who had a fabric solution the day before this was announced, NSX, every one of them now has a fabric decapsulation agent for NSX. Well, that's a pretty stupid idea. Why would I decapsulate the packet before it hits the fabric? Easy, because when I get inside of fabrics, I can do things like multipathing. I can use the additive bandwidth of every switch that's added to the fabric to make everything that much faster. And then on the other end, I just recapsulate the packet and off we go. I was sitting in an airport in St. Louis. I'm like, why is everybody trying to screw with this traffic? Because once they get rid of it out of the tunnel, they can do things to it. Because tunnels are stupid. Just like a VPN tunnel. Once I encapsulate things in a VPN tunnel, I can't see them anymore. I can't do QoS on tunnel traffic. Why? Where's the header? Believe it or not, the hardest thing in MPLS had absolutely nothing to do with writing the MPLS protocol. LDP is stupid simple. But traffic engineering MPLS tunnels is a nightmare. Walk up to any service provider and just say MPLS TE, and if he doesn't tear his hair out and run screaming out the door, he's probably already crazy. I'm not saying NSX is a bad solution. I'm not. It's a good solution. I just don't necessarily agree with everything that they're taking into account. I don't like the verbiage that they're getting rid of your networking team, because that's how you create enemies. I think a better thing would have been, let's work with the networking team to optimize the underlay network for NSX traffic. But what is the underlay? Well, you guys have been dealing with it forever. told you, I'm going to make that t-shirt one day. I'm going to wear it to this event. So underlays are traditional networking. That's all they are. It's wires. It's protocols. It's bum traffic. And if you ever hear the term bum traffic, that's easy. Broadcast, unicast, multicast. The 3 network killers. Actually, U stands technically for unknown unicast because unknown unicast frames become broadcast frames. So we have to optimize our underlay networks because think about driving a Ferrari on bald tires. You could have the most hot sports car on the planet, and if the tires fall off of it, it's going nowhere. If you look at the architectural implementation guides for a lot of these overlay protocols, they assume that everything works in your underlay. This is where the real network engineering is going to happen. Fabrics, multi-links, high performance stuff. We have to keep in mind that it all works together. A recent article I wrote about the problems that you're seeing with VMware wanting to encapsulate all your traffic in a tunnel and shoot it over the network. They're not listening to what the network is telling them. Applications need to be responsive to network demands. Just like everyone's been screaming for years that the network has to understand what an application needs, we're creating this artificial event horizon. That event horizon means that no information is passing back and forth. And I know that Hawking just wrote that event horizons don't actually exist because that means that the classical black hole can actually now exist. There are apparent horizons where information appears to settle and then it just disappears into thin air. But if you're not listening to what I'm saying about traffic conditions, QoS, link costs, and things like that, I don't necessarily care what you have to tell me. I need 10,000 megabits of bandwidth or this isn't going to work. Okay, that's great. You do know that if you go that way, you're going to fall off of a cliff because that route is stuck and active. Take everything into account when you start building these. Because if you don't, you're going to be in a world of hurt. So we have SDN, we have NFV, we have overlays and underlays. We have all of the Lego components to build awesome networks. And we've been doing it for a while. Coho's doing it with SDN. They're using SDN to fix storage problems. At ONS, there were other vendors that were starting to use it to do other things, such as SDN wireless, because guess what? Nobody in this room is plugged in right now, except for Ben, but that's a different story. You don't walk into a building and ask where Ethernet jacks are anymore. What's your wireless key? Where's your guest access methodology? So if you want to run end-to-end SDN across a network, you can no longer talk about using wires to do it. Some of the most crazy things that I thought I'd never think of in the world 2 years ago. You want to run OpenFlow on a wireless controller? What's wrong with you? But when you think about it, a wireless controller has been doing what OpenFlow wants to do to networks for years. But wireless solved their problems because one of the initial problems we had with OpenFlow was what happens when I jam so many entries into a CAM table that it basically barfs on me? I can only feed stuff to that switch so fast. Well, wireless already figured that out. I have to do something about local switching for traffic because if I try to send it all back through the controller over tunnels through an overlay network, problems start happening. Well, now we're turning that paradigm back on its head. What if I could use OpenFlow to program those access points? That also gets around the idea that there's a CAP-WAP, which is an industry standard protocol for wireless configuration that's not standard. Everybody has their own flavor of CAP-WAP. However, if we use OpenFlow to program those wireless access points, wow, that's amazing. Security is huge, and if you don't believe that, Martine's latest paper is all about security. If the genius who invented OpenFlow is now saying that it needs to be used to make security better, somebody should be listening to him. So now, all of those problems that I have whenever my target card gets breached by some point of sale malware, no, now I know where the data path went. Now I know every device that got touched in the data path, and I can create restrictions. Plexi's doing that. So if you're not familiar with Plexi, it's a bunch of geniuses that created an idea around affinities. So we found out that when we charted big data in a data center, we found that a whole bunch of servers kept talking to the same server. You know, it's like at a party. Everybody tends to kind of cluster around the same 3 or 4 people, and those are the conversation starters. Well, that's easy to chart. I just give them more performance. But what if I want to create the opposite situation? What if I want to ensure that the payment card server never, ever, ever talks to an unsecured network or an unsecured server? Creates a whole bunch of compliance headache relievers, because now I don't have to worry about whether or not that my needs are being met. All I have to do is go pull up a report from the controller that says 0 packets went from here to there. You know, it's a brave new world for security. And now I need to integrate all of this together. So the really smart ones are going out and saying, well, controllers by themselves don't do you any good, but if I put it in front of a network management system like OpenView or Insight Manager, or name your favorite one here, and I can integrate all of those pieces together, now my virtualization team really can become my networking team, because I don't have to worry anymore about single pane of glass. I'm the second one to say it because I hate that term, because there's no such thing as a single pane of glass. It all looks like stained glass to me. So I have to shell out of one application to start working on another. And even when it's integrated, like in vCenter, yeah, you think the update manager UI looks the same as the rest of that? No, because it was developed by a totally different team and they just bolted it on. Like, you got to change these 3 buttons and make that label different. That's not integration. We all have to start making it work together, which means just like Martine at Clean Slate, we have to start imagining now what we have with these protocols and what we can build our networks out of. So congratulations, guys, you're all networking people now. Well, you can get your certificates when you walk out. But when you go back to your establishments and you start talking to the people in the cave that deal with the bits and the wires and stuff like that, and they start saying things like service chaining or VTAPs and things like that, now you're going to understand what they're talking about. You're going to understand why they're so important. But of course, once the networking guys figure out that you know them and you speak their language, you're probably going to get upset. So you don't know anything about networking. That torpedo didn't self-destruct. You heard it hit the hull. And I was never here. Thank you for listening to me wax intellectual or something appropriate to networking. Please ask me questions.
What do you think about Open Contrail?
Open Contrail, Open Contrail is a great idea. So Contrail was doing it right when they got bought. And just so if you're not developing a solution, you better go find one. It's 1:55, the lights are on at the bar. You better find a friend, because you either have the expertise, you've developed it like a minor league farm system, or you go out and you find it. And I'm not speaking ill of Open Contrail. I actually do like it. I've been briefed on it a couple of times, and they're doing it right. And they're doing it right because they're integrating it up and down the stack at Juniper. Okay. Jeremy Schulman, who's a really brilliant guy, was showing me some automation stuff that he's doing in Junos. You guys are familiar with Puppet, right? Most everybody in the server world, when I say Puppet, they're like, yeah, man, Puppet is awesome. What if I could use Puppet to provision my switches? He showed us that at Networking Field Day 5. He's like, yeah, so I'm going to use this Puppet agent. I'm going to boot this switch, and it's going to get all of its VLAN information and automatically create a user account for an SSH, and then it's going to email me when it's done so I can log in and finish these last couple of settings that are specific to that switch. And every one of the networking guys went, that's awesome! And the server guys in the stream were like, it's old hat. These are the kinds of things that we've been dealing with for years. But yeah, Open Contrail, awesome idea. I can't wait to see what they do with it.
So does software-defined networking completely change the idea of convergence when there's a route, like a route that's down, instead of all the routers having to talk to each other to define a new route, they all just send information to the controller and the controller says, okay, here's your new route?
It can. You can cause that to be triggered. So what is a routing table really? A routing table is a collection of everything in the network. Well, in the old days, when routing protocols needed to be cheap, dumb, and fast, we created RIP. RIP is not deterministic. RIP is routing by rumor. It operates because I know about the routes that I can talk to next. And I know that if it's not one of these guys, I have to send it that way, and hopefully it'll eventually end up where it is. Well, what was the big leap in networking? It was Dijkstra's algorithm was creating link state databases, because now I know the link state of all of the devices in an area. So now I know that this link is down, so I need to recalculate a path cost over here. But I still, because of the architecture of ISIS and OSPF, I don't have a vision of the entire network, because I have to create these little boundaries to prevent loops. Well, now a controller doesn't have that problem anymore, because a controller can know the state of every node in the network. So yeah, routing protocols aren't going to go away, but with OpenFlow, why do I need one? Because when a route goes down, I can jam a new entry and a CAM table into a switch that fast. And then send you an email and say, hey, guess what? You want to look at, think about the things that Arista was doing with some of their switches. They were solving real problems. Like, if I dump a routing table on a device, like if I reboot a router, it has to reacquire all of its routes. It has to talk to neighbors. It has to get a view of the network. Well, if it was just a simple reboot, why did the state of the network change? So one of the things that Arista did was they actually created a database on the switch, and when you reboot the switch or the router, the state table for routes at the time the switch went down is immediately repopulated, and then it just asked, did anything change in the 5 minutes since I talked to you last? But the reason that that's awesome is because now not only do I have a database that tells me what the routes are, I can do show IP route at and tell you at a specific time what a routing table looked like. 5 minutes ago, everything worked just fine. Now it doesn't. What did you touch?
Nice.
Only works on Arista now, but with OpenFlow, I can do that for my entire network. So I can see how you could say that it's going to be less hairy. Now, OpenFlow's still got some issues. They're working on it.
Let's say you're sold on SDN and the vision you lay out there. So what do you buy, and how do you manage the risk? I mean, I think I understand OpenFlow and open source enough to say that there could be a risk of that forking. Is there a risk of OpenFlow forking? And then if I buy my switch that's OpenFlow compatible and the whole movement goes in another direction, what happens?
There is that risk. I won't lie to you. Now, I will tell you that OpenFlow is tightly controlled by the Open Networking Foundation. Martin developed the initial specs. He donated to ONF. ONF is the arbiter for what OpenFlow is. So, and by the way, getting into the ONF is not cheap. It's $10,000. I actually at one point joked that I was going to start a Kickstarter and I was going to put Greg Farrow on the ONF. I got DMs that said, please don't do that. I wouldn't worry so much about OpenFlow forking because the people who would have forked it have a good voice on the ONF board. A lot of them are friends of mine, Kurt Beckman and Dave Meyer. They're doing good work. I would be more worried about the hardware not supporting OpenFlow. And it's a big deal. Actually, an article that went out today, and I was telling some of you about it in the limo. OpenFlow 1.0 is basically the, hey, we support OpenFlow, can we put a sticker on this? OpenFlow 1.0 is useless. It doesn't really do a whole lot. Things like Q and Q tunneling, IPv6 support, doesn't exist. OpenFlow 1.3 is the spec that everybody wants to be on. Like I said, OpenFlow 1.3 is a lot like Windows XP. The one you want to be on and the one you can be on for a while. You're not going to get all the latest, hottest, cool stuff, but you're also not going to fall over because all of a sudden you don't support a printer. Or in this case, you don't support IPv6 or multiple clustering of devices to, because the original OpenFlow spec had a real big problem about what happens when you have two controllers in the network. But as far as open source, because I've seen that problem too. It's like, you know what, that developer called me a nasty name at the mixer last night, so I'm going to go fork his whole project. You can't really do that with this. It's open, it's free as in freedom, not free as in beer. So the ideas are there, and we know what we want to do with it, but you can't just go pull the source code from Git and then screw with it a whole bunch, and then push it back up and go, well, it's now OpenFlower.
What about the idea that a lot of people are going to face in the coming months and years that network virtualization is like Obamacare? You can use your switches today, period. You can keep your topologies, period. Because what happens when you wanted to jump into Open Daylight, but your current Cisco switches don't jive? You want to run ACI. Oh, sorry, you're running a stack of 3750 top of racks. It's not going to jive. Like what's going to happen where, although the paradigm shift is there, we still do have a lot of bare metal network gear that isn't going to be able to take it on. So there will be a capital cost to a lot of shops it's going to take a while maybe to get those folks to jump in.
How old's your laptop?
About 18 months.
About 18 months. The one before that, why did you upgrade?
Because my company said it's time for a new one.
Okay. Would your old laptop run Windows 8?
It would.
It would. Good?
Not necessarily, but it would.
So, is it the responsibility of the protocol writers to create a software revision that's installable on every piece of hardware on the planet? Or is it the responsibility of hardware manufacturers to understand that if the support is going this direction, maybe I need to worry about making sure my latest, greatest, awesome stuff supports it? We have hardware compatibility lists for a reason, right? Windows is in the mess that it's in because they have to support every piece of hardware ever made. Say what you will about Steve Jobs and Apple, but when you have an HCL that's this long, it's real easy to write stable drivers.
Yep.
The entire world of installable hardware on a Mac could probably fit in Cliff Notes. And you know what? For better or for worse, rarely does hardware crash in Apple. And I'm not saying that because I use a MacBook or anything like that. I'm just saying that I don't have to worry about installing software that's going to support 1PK or it's going to have an API call. Now, some people are doing that. I know Cisco is trying to drive 1PK into everything they touch because if they have this giant install base, you might as well take advantage of it. But for those people that are just coming out like Cumulus Networks or Pluribus Networks, and they're saying, well, we have all this software and this amazing new hardware, just look at the next time you have to upgrade, because switches don't run forever. As much as we would like them to, eventually we get to the point where they won't. So if you're going to have to install it anyway, you might as well look at upgrading to us because we're cheaper. So we've already baked in our development costs. You know, you might as well go with us. And then guess what? You get faster switches and they run OpenFlow. Anybody else?
I don't want to raise this as a political question, but the whole NSX Cisco thing, and just architecturally, forget about the politics, the technology of it, and one versus the other. You mentioned some of the, possible limitations of NSX. So,
Yeah. What are the limitations of Cisco too?
Yeah, what are the good bits
that.
of each one, and where do you see that? Forget about, as I say, the companies, the technology. What do you think of each one and what's been done and where it's
Honest
going?
6 years are burning right now. I can tell he's getting ready for it.
Yeah, he's probably
Or
going to
can
jump
you make
out of the
that?
camera
Can you
and
make
stuff.
that call, or just have to see?
They both solve the same problem in a much different way, but it depends on your visibility into it. So obviously NSX is going to be appealing to you guys because it was built for virtualization people. And virtualization people don't care about the underlay. I just build tunnels everywhere and everything works. And you know what? It does. Now there's going to be limitations. Sometimes if you don't play nice with NSX, you're probably not going to work right. It's the reason why they had to partner with companies like Palo Alto. But on the flip side of it, Cisco, and you're specifically talking about ACI, application-centric infrastructure. ACI works because they're looking at the networking side of things, going, I've got this entire collection of devices that need to be able to have information about application needs. So the automation piece happens whenever you go into the APIC, the Application Policy Infrastructure Controller, that will be released shortly. And I say I need to stand up a new web service. And it basically goes out and it has hooks into everything else in the network, and it jams all the information down in there, automatically creates the VLANs and the rules that say these things can go everywhere. Same problem that NSX has. If you don't have a shim that talks to ACI, you're an island and I can't do anything for you. The best I can hope for is I can either screen scrape a config and push it down to you through Telnet, or I can go find a CLI jockey and say, why don't you copy and paste this piece of information into the switch? Cisco's solution is going to appeal to networking people because it looks like what we think networking should look like. VMware's solution is going to appeal to virtualization people because it looks like what they think networking should look like. Pointy, clicky on this side, cody typing on the other. For good or for bad, I'm not going to make that call. And I'm waffling here as any good politician would. I'm not going to make that call because you know what? I'm friends with Martine, I hope now. Maybe not after the picture. I'm friends with Joe, although after last night, Joe may not want to be my friend anymore. They're both great guys and they're both really, really smart. And they both have a solution to a problem that everybody has. Who's going to win? Well, the better solution is going to win. Who's going to determine that? Not me. I just sit up here and run my mouth. The winner is going to be whoever gets bought the most.
The winner is the customer.
Winner is the customer because he gets a solution. He gets the problem solved.
Unless he buys the wrong solution.
If it's not the wrong solution, if it solves your problem.
Exactly.
Whether it's Republican or Democrat, whether it's ACI or NSX, if it's your solution and it's your problem is solved, you won.
If the solution works for you and it's not abandonware in 6 months, then it's a win. All right.
I'd like to be able to take bits from both,
Yeah.
but that may not be possible for other reasons.
No, I think eventually it will. They'll have to interoperate. You know, the posturing is there. So there will be a peace treaty
A new interop.
eventually.
Yeah.
And just so you know, so NSX only works with the ESX hosts, but Martine's other project that he was working on before it got bought, Nicira, interoperates with almost everything. So Nicira is probably going to be the way forward for a lot of people who aren't running that. You know, OpenStack, Hyper-V, what have you. Be educated about what you need and critically evaluate every solution. Because No one-size-fits-all solution truly is one-size-fits-all, but if you can take the bits that you need and make your solution work, then there's no reason why they can't play nice together.